If you are using accuracy as the primary metric for your AI model, you might be building something that's doomed to fail. But why? Because accuracy is often misleading. In this video, I'm going to show you why accuracy isn't always enough and introduce you to the other metrics that can make or break your model. And trust me, it's not as complicated as it sounds. So stick with me till the end. Let's start with the most familiar term, accuracy. Imagine you are a teacher grading an exam. If 95 out of 100 students got the answer right, the accuracy is 95%. You would feel pretty good, right? Well, in machine learning, accuracy works in the same way. It's simply the percentage of correct predictions your model made out of the total. But here is where it gets tricky. Let's say you are building an AI model to detect fraud in bank transactions. 95% accuracy sounds amazing, but if only 1% of the transactions are actually fraudulent, your model might just predict no fraud for every transaction and still gets an accuracy of 99%. That's where the problem is. To closely analyze what's going on, we need to break things down using a confusion matrix. Think of this as a table that shows us not only where our model got things right, but also where it went wrong. Here's how it works. True positives are the cases where the model correctly predicts fraud when there is a fraud. False positives are the false alarms, when the model predicts fraud but there's none. False negatives are when the model misses actual frauds, and true negatives are when the model correctly identifies a non-fraudulent transaction. In our fraud detection example, accuracy alone would miss the fact that your model might have way too many false positives or false negatives, and that's where other metrics like precision and recall come in. Precision asks the question, when your model says fraud, how often is it actually right? In other words, precision is all about reducing false positives. If your model is flagging a ton of false alarms, you are going to lose trust. Nobody wants their account frozen for no reason, right? High precision ensures that when your AI raises a red flag, it's almost always on point. But here's another catch. Focusing only on precision means your model might become too cautious. On the flip side, we have recall. This metric asks, out of all the actual fraud cases, how many did your model catch? In this case, recall is like a wide net. You want to catch every possible fraudulent transaction, even if it means sometimes flagging innocent ones. Balancing these two, precision and recall, is the key for optimal model, but it's not always easy. So what do? This is where F1 score comes in. Think of F1 score as the negotiator between precision and recall. It takes both into account and gives you a single number that tells you how well your model is doing overall. It's a harmonic mean of precision and recall, meaning it rewards balance. If one of them is too low, your F1 score will reflect that. Let's say your model is great at catching all fraud cases. That is high recall, but it also flags too many innocent transactions, which indicates low precision. In this case, your F1 score will also drop, warning you that your model is not as perfect as it seems. The F1 score is very useful when you are dealing with an imbalanced dataset, like in our fraud detection example, where most of the transactions are non-fraudulent. It's a solid way to measure overall performance without leaning too heavily on one side. Now let's zoom out. Imagine you could see the performance of your model at every possible threshold, not just where you set it, but across the entire spectrum. That's where the AUC-ROC curve comes in. The AUC, or area under the curve, gives you a broader view of your model's ability to distinguish between classes. In this case, fraud versus non-fraud. The closer the curve is to the top left corner, the better your model is at separating true positives from false positives. And if area under the curve is close to 1, your model is performing well. But if it's closer to 0.5, it's no better than flipping a coin. The AUC-ROC curve is crucial when you want a full picture of how your model is making decisions at different thresholds. So now the question is, what does all this mean for you? Well, instead of relying on just one metric like accuracy, you now have a toolkit full of different metrics for classification model, each giving you a unique insight. Accuracy can give you a quick snapshot, but precision and recall tells you how reliable your model's decisions are. F1 score gives you a balance, and the AUC-ROC curve gives you a comprehensive overview of your model performance across different thresholds. In real-world AI projects, choosing the right metric depends on the problem you are solving. If you care more about catching every case, you will go with recall. If you want to make sure you don't raise too many false alarms, you will go with precision. If you are dealing with imbalanced dataset, you will probably choose F1 score. And if you want to analyze your model for the entire spectrum of threshold, you will choose AUC-ROC curve and build a smarter, more effective AI model. Alright, now it's your turn. If you are building an AI model, let us know in the comment section which metric would you prioritize for your use case. That's all for this video. If you found this video helpful, don't forget to hit the like button and subscribe for more videos like this.